Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring imaginary numbers, and we'll show how the imaginary numbers are used to simplify square roots of negative numbers. Now, before we get into how to do that, let's just look at a definition of the imaginary unit. So, in algebra, we define the variable I to be equal to the square root of negative 1. Now, what that means is that if you square the value of I, you would just get negative 1. So if you have the square root of a negative number, in previous courses you were probably told that something like this is impossible to evaluate. But once you add the imaginary number system, you are able to simplify square roots of negative numbers. And let me show you how we would do that. So the square root of negative 7 could be rewritten as the square root of negative 1 times the square root of positive 7. And we know that we defined the square root of negative 1 as being equal to I. So when we simplify square root of negative 7, our answer would just be I square root positive 7. All right, let's look at a few more examples. Simplify each of the following square roots in terms of I. So in problem A, we have the square root of negative 49. So the first thing I'm going to do is rewrite this as the square root of negative 1 times the square root of positive 49. And we know the square root of negative 1 is equal to I. We know the square root of 49 is 7. Now, you could write it like this, but it's more conventional to write this answer like this, 7I. All right, look at problem C, the square root of negative 32. So I'm going to rewrite that. I will take the square root of negative 1 out first. And then for 32, I'm going to split it into the square root of 16 times the square root of 2. So if I multiplied all those together, I would get negative 32. So I know the square root of negative 1 is I. I know the square root of 16 is 4. And the square root of 2 is just the square root of 2. Now, to simplify my answer, I'm going to write it as 4I square root 2. All right, problem D. We have the square root of negative 13. So I'm going to rewrite this as square root 1 times square root 13. The square root of negative 1 is equal to I square root 13. So the simplified form would look like this. Now, you could also write it like this, square root 13, with the I at the back. I don't really like writing it that way because sometimes it looks like the I is under the square root, so I don't recommend writing it like that. I recommend putting the I in front of the square root symbol. All right, problem F. We have 4 times the square root of negative 75. So I'm just going to simplify this. 4 times square root negative 1. And for 75, I'm going to break it down to 25 and 3. So this would be 4 times I times 5 times square root 3. Now multiply the 4 and the 5 together to get 20I square root 3. Now, in our next set of problems, we're going to learn how to simplify powers of I. Now, to do that, we're going to take our original definition. We know I to the 0, anything to the 0 power is 1. And I to the 1 power is simply I. Now, if you square I, you're going to get negative 1. And I cubed would just be negative 1 times I, or negative I. Now, I to the 4th power, let me write this down, could be the same thing as I squared times I squared. And we already know that I squared is negative 1 times negative 1. So negative 1 times negative 1 is positive 1. So I know that I to the 4th power is positive 1. Now, for I to the 5, we could do I to the 5. we could separate it into I cubed times I squared, because those are both things we already know. We know that I cubed is negative I, and we know I squared is negative 1. A negative times a negative is a positive, so that would simply be I. Now, I want you to notice what's happening, this pattern we're developing here. All right, so let me delete that. Now let's look at I6. There's a couple different ways we could rewrite I6. One of the ways is to multiply I to the 4 times I to the 2. And we know I to the 4 is 1, and we know I to the 2 power is negative 1. So 1 times negative 1 is negative 1. Now, look what's happening in our table here. Let's go back to I to the 0. We have 1, I, negative 1, negative I. Then we have 1, I, negative 1. So this is going to be negative I. And then the pattern would begin to repeat itself. I to the 8 would be 1. So our pattern repeats every fourth time. Let me erase this. Okay. Now, to help us remember how to simplify powers of I, we can use something called an I clock. So in this little circle, we have I. On the inside, we're going to put our possible remainders. So remainder of 0, remainder of 1, remainder of 2, remainder of 3. Okay? And when we had 0 power, our answer was 1. I to the 1 was I squared was negative 1, and I cubed was negative I. Now we're going to use this little I clock to help us simplify these different powers. So I to the 15, what you're going to do is you're going to take the 15, and because this pattern repeats every fourth time, you're going to divide it by 4. So 4 goes into 15 3 times with a remainder of 3. Now this is the only thing that's important, is your remainder. So you go over to your I clock. When there's a remainder of 3, your answer is negative I. All right. So I34, again, you'll take your power and divide it by 4, and you're trying to find your remainder. So 4 goes into 34 8 times with the remainder of 2. So again, all you care about is your remainder of 2. So when according to our clock, when our remainder is 2, our answer is negative 1. Problem C, we have 5 times I to the 41st power. So this is going to be 5 times something. To figure out what the I to the 41st power is, we're going to take 41, divide it by 4, and that would be 10 remainder 1. So when our remainder is 1, it simplifies to I. So this would be 5I. Now, we'll be referring back to that clock on our next set of problems, so keep it handy. Okay. Example 4. Simplify each of the following. So in problem A, we have 4I to the 28th power times 6I to the 6th power. So what I usually do is just multiply these, just pretending like I is a normal variable. 4 times 6 is 24, and then we would have I, 28 plus 6 is 34 power. So normally, if this was just a normal monomial problem where you were multiplying two monomials together, you'd be done. But with our imaginary unit, it can be simplified. So I think we already found out what I to the 34 was in a previous problem. Let's go back and look. Yep, right here. We found that I to the 34 was negative 1. So this is 24 times negative 1, which gives us negative 24. All right, problem B. We have negative 4I times 2I times negative 9I. So the first thing I'm going to do is multiply my coefficients. So I'm going to multiply the negative 4 times the 2 times the negative 9. So that would give me 72. Now I'm going to multiply the I. So I times I times I would be I to the third power. Now, again, normally this is where we would stop, but I can simplify I to the third power. So I'm going to look back at my clock. When our exponent is 3, that's negative I. So this is 72 times negative I, which would be negative 72I. Okay. Problem C. 2I raised to the fourth power times 5I. So this is 2 to the 4 times I to the 4 times 5I. So 2 to the fourth power is 16. I to the fourth power is 1 times 5I. So now I can multiply 16 times 5, and that would give me 80I. All right, problem D. I times the square root of 3 squared times negative 3I squared. So this is I square root 3 times I square root 3 times negative 3I times negative 3I. All right. So let's multiply the first two together. I times I would be I squared times square root 3 times square root 3 is square root 9. Negative 3 times negative 3 is positive 9. And I times I is I squared. Now, we already said that I squared was negative 1. So this is negative 1. The square root of 9 is 3. The 9 can't be simplified. And I squared is negative 1. So now we're just going to multiply this all together, and that would be 27. All right, E, the square root of negative 18 times the square root of 5. So let's simplify the square root of negative 18. That would be square root negative 1 times square root 9 times square root 2 times square root 5. So the square root of negative 1 is I. The square root of 9 is 3. The square root of 2 will not simplify. The square root of 5 will not simplify. So 3 times, 3 times I is 3I. And square root 2 times square root 5 is square root 10. Problem F. We have 2/5 times the square root of negative 75. So this will be 2 over 5. Now I'm going to simplify square root of negative 75. So I'll start by taking out the square root of negative 1. And for 75, I'm going to break that down to square root 25 times square root 3. So this would be 2/5. We know the square root of negative 1 is I. Square root of 25 is 5. And then square root 3. Now I'll multiply 2/5 times 5, and that will give me 2I square root 3. Now, in our last set of problems, I want to show you when do we use imaginary numbers in the real world. So we use imaginary numbers in the real world when we're coming across equations where we end up with a negative square root. So let's look at problem A. We have negative 1/2 x squared plus 2 is equal to 26. So the first thing we're going to do to solve this is we're going to subtract the 2. And that will give us negative 1/2 x squared equals 24. Now we'll multiply both sides by the reciprocal, which in this case is negative 2 over 1. And that will give us positive x squared is equal to negative 48. Now we'll take the square root of both sides. And when we do that, that will give me x on this side. And over here, I'll have plus or minus the square root of negative 48. So what happened is we ended up with a negative under our radical. So that's when we're going to use our imaginary unit I to simplify this. So to simplify it, I will take out the square root of negative 1 first, and then I'll rewrite square root 48 as square root 16 times square root 3. So this will be plus or minus I times 4 times square root 3. And we'll clean that answer up a little bit. Plus or minus 4I square root 3. Okay. Problem B. We have negative 2/3 x squared minus 1 is equal to 17. And we want to solve for x. So I'll start out by adding 1 to both sides. So negative 2/3 x squared is equal to 18. Then I'll multiply by the reciprocal, which would be negative 3 over 2. So that gives me positive x squared. On this side, negative 27. Take the square root. So x would equal plus or minus the square root of negative 27. And I can simplify that. Rewrite this as square root negative 1, square root 9, square root 3. So this would be plus or minus I times 3 times square root 3. So x equals plus or minus 3I square root 3. All right, problem C. We have x minus 6 squared plus 20 is equal to 0. So I'll start off by subtracting 20 from both sides. So x minus 6 quantity squared is equal to negative 20. Now take the square root of both sides. So we have x minus 6 equals plus or minus the square root of negative 20. Now I'm going to simplify that. That would be plus or minus square root negative 1. And then for 20, I'll break it down to square root 4, square root 5. So x minus 6 equals plus or minus I times 2 times square root 5. Now I'll bring the 6 to the other side. 6 plus or minus, and then I'll simplify that to 2I square root 5. Final answer. All right, pause the video and try problem D on your own. All right, let's see how you did. I started by adding 64 to both sides, and then I divided by negative 8. So I got x plus 2 quantity squared equals negative 8. I took the square root of both sides, and that gave me x plus 2 equals plus or minus, and then I simplified this to square root negative 1, square root 4, square root 2. So x plus 2 equaled plus or minus I times 2 times square root 2. And then I subtracted 2 from both sides. So negative 2 plus or minus 2I square root 2. And that concludes today's lesson, Introduction to Imaginary Numbers.